In this session, we're going to start to look at the algebra of matrices. A matrix is a rectangular array of numbers enclosed by square brackets. For example, 2, -1, 5, 4, 7, 3, with square brackets around it, is a matrix. And when I read matrices, I read them across their rows most often. Therefore, since I read 2, -1, 5, and then 4, 7, 3, this matrix has 2 rows. And as you can see, this matrix has 3 columns. And a matrix that has 2 rows and 3 columns is referred to as a 2 by 3 matrix. 2 by 3 being the dimension of the matrix. And so, for instance, a 5 by 1 matrix would have 5 rows and 1 column. The way I remember which one comes first is that it's in reverse alphabetical order. Rows comes first and then columns comes second. Okay. We can do things with matrices. We can add and subtract them. We can multiply them by a number, and we can multiply them by each other in certain cases. Multiplying them by each other is in a different session. But in order to add 2 matrices together, the dimensions must match. And the same is true of subtraction. All I'll say for the moment is adding will go exactly the way you think it will go. We can multiply a matrix by a number. Before we get to that, let me do a little bit of notation here. This matrix that we wrote down, 2, -1, 5, 4, 7, 3, I'm going to denote by an A. And what you will notice is that matrices are denoted by an uppercase letter and not a lowercase letter. Makes things just a little bit easier to follow. We can take, say, the number 3 and multiply it by the matrix A. This is called scalar multiplication, 3 being a scalar. Scalar because it scales the numbers up and down, right? I was in a class once, and I asked the class if they knew what a scalar was, and this dude goes, "It's a derogatory term for a lizard." It was really funny. Anyway, 3 times the matrix A can be written as 3 times 2, -1, 5, 4, 7, 3. And what the 3 in front of the matrix does is it multiplies all of the entries by 3. And so the matrix becomes 6, -3, 15, 12, 21, 9. And that's how we multiply a matrix by a number. And we're going to add and subtract matrices as our examples come up. Our first one, oh my gosh. Okay. We're given 4 matrices. Let A equal 4, 6, 1, 3. Again, those are rows. Let B equal 2, 5, 3, 7. And let C equal 2, 3, 1, 0, 0, 2. And then D is 10, 20, 30, 20, 10, 0. We're asked to perform indicated operations if possible. The first one being 2a minus 3b. Well, 2a minus 3b means to multiply 2 by the 2 by 2 matrix 4, 6, 1, 3. And then -3b means we're supposed to multiply b by 3 and then subtract if you like. So 3 times 2, 5, 3, 7. I find it easiest to multiply by the numbers first and then deal with the addition or subtraction second. And so in this case, 2 times 4, 6, 1, 3 is going to give me 8, 12, 2, 6. And then 3 times 2, 5, 3, 7 is going to give me 6, 15, 9, 21. And then finally subtracting those two. Now, when I said you subtract the way you think you would, what I mean is we have 8, 12, 2, 6, and then 6, 15, 9, 21. Since 8's in the first position of the first row, 6 is in the first position of the first row of the other matrix. We're looking at 8 minus 6. That's 2. And then 12 minus 15. That's negative 3. And then 2 minus 9. That's negative 7. And then 6 minus 21. That's negative 15. Couldn't really be any easier. That's it. I know. Next, C plus D. Well, let me write down what the matrices are. So C plus D is 2, 3, 1, 0, 0, 2, which by the way is a 3 by 2 matrix, plus 10, 20, 30, 20, 10, 0, which is also a 3 by 2 matrix. And notice those dimensions match. We won't have any trouble. We do this entry by entry, and so 2 plus 10, 12. 3 plus 20, 23. And so on. So our matrix becomes 12, 23, 31, 20, 10, 2. That's what happens when we add C and D. Next, A plus C. Let's write down what those matrices are. So I've got 4, 6, 1, 3 plus 2, 3, 1, 0, 0, 2. Everyone has to have a partner. I could pair 4 with 2. I could pair 6 with 3. 1 with 1. And then 3 with 0. But then the 0, 2 at the end of the bottom row of the matrix C has no friends. Therefore, this computation is not possible. A being a 2 by 2 matrix, C being a 3 by 2 matrix, they don't have matching dimensions. In order to add or subtract matrices, the dimensions have to match. And next, solve the matrix equation 2a equals b minus 3x for x using a and b as defined on the previous slide. Because all of the letters in this equation, 2a equals b minus 3x, are uppercase, I know that they all represent matrices. So I'll rewrite the equation down here. 2a equals b minus 3x. I'm going to solve this right now symbolically like I would any linear equation. And so first, I'm going to subtract b from both sides. 2a minus b equals negative 3x. And then I'll divide both sides by negative 3. Actually, the way I'm going to do it, I'm going to write x equals, because I like to have my x on the left-hand side. I'm going to say x equals negative 1/3 times the quantity of 2a minus b. You see, that's how I'm going to write down that I'm dividing both sides by negative 3. And so what I need to do is I need to find 2a minus b, and then divide that by negative 3. Well, let's see. 2a minus b, using the a and b from the previous slide, is 2 times 4, 6, 1, 3, minus 2, 5, 3, 7. Go ahead and perform that operation and then come back to the video. Okay, I've got that 2a minus b is equal to 6, 7, negative 1, negative 1. Well, x, according to what we did when we solved the equation symbolically, is negative 1/3 times 2a minus b. So times 6, 7, negative 1, negative 1. Ew! Yeah, I know, it's not all peaches and roses. X is equal to negative 2, negative 7/3, 1/3, 1/3. I don't really like it any more than you do, but guess what? We don't have to do anything with it because we're done with that one. On to the next. Here we have a matrix equation. Solve for x and y, and we have the matrix xy, negative y, x, right, that 2 by 2 matrix, minus yx, x negative y, is equal to 4, negative 4, negative 6, 6. How the heck am I supposed to do that? Well, first I'm going to perform the operation on the left-hand side. It says to subtract, so I'm going to subtract. I'm going to write down a new matrix, x minus y minus x, that's the first row, negative x minus y, x plus y. That's the matrix on the left from subtracting, and that's supposed to be equal to 4, negative 6, 6. There's only one way that two matrices can be equal, and that would be if the corresponding entries are all equal to each other. So the entry in the first row and first column should be equal in both matrices. Incidentally, just a notational thing, we saw that we started calling matrices A, B, and C, right? So A, like uppercase A, was a matrix. The entries are referred to using lowercase letters and then subscripts. So the entry in the first row and first column is the entry A11. In the first row and second column, it's going to be A12. So a matrix entry is referred to using a double subscript. The first subscript tells me what row I'm in. The second subscript tells me what column I'm in. Back to our regularly scheduled programming. If we're supposed to have that A11 equals A11, then in this case what we have is that x minus y is equal to 4. And if A12 is supposed to equal A12, then we have y minus x equals negative 4. Folks, these are the same equation. I have two variables, though. I hope I can end up with two different equations. Well, we also have that negative x minus y is equal to negative 6 from A21. And then from A22 of each matrix, we get that x plus y is equal to 6, which is again a pair of equations that matches. Oh, look, I have a system of equations. X minus y equals 4, negative x minus y equals negative 6. I'm not going to use the other pair too. It doesn't matter. It's all the same. So I'm going to go ahead and solve this system real quick. I want you to do it too. Pause the video, find x and y, then come back. So I used elimination, and I got xy is equal to 5, 1. Why didn't I solve for a matrix? Folks, we were solving for lowercase x and y. Last time, we were solving for uppercase x. I know, subtle. Next, same instructions, solve for x and y. We have the 2 by 1 matrix. We also call that a column matrix. X minus 3y in the top row, and then 2x plus y in the bottom row is equal to 1, negative 5. Things pair up. X minus 3y is equal to 1. And 2x plus y is equal to negative 5. And this is a system that we know how to solve. So, do the same thing we did last time. Well, slightly different steps. But go ahead and solve the system and then come back to the video. And I used elimination. I eliminated the x's to come up with x, y is equal to negative 2, negative 1. Now how would I verify that my answer is correct? Just like we would in any other case. We'd put negative 2 in place of x in the original matrix equation, and then negative 1 in place of y, and then see that the top row becomes 1 and the bottom row becomes negative 5. That's it.